So what is the geochemical cycle? You can say it is the interaction of any element from atmosphere, then hydrosphere, then biosphere, then geosphere. So geochemical cycle, it is different for different element. Different element will have a isolated or a different cycle which will not interact with the other element. So that's why I have to study them separately. So I have to study them separately for geochemical cycle. So let's see. So geochemical cycle is the interaction with four components of the Earth system. That is your geosphere, and solid earth, hydrosphere, biosphere, and atmosphere. How these elements are mobile in these four main part of the main system of the Earth. So every element has a unique biogeochemical cycle. There are biological process, chemical process, and physical process that helps to move the to rotate the ion within the atmosphere, biosphere, and geosphere. Each cycle have two more interconnected components. One is more exogenic component, another is endogenic component. Exogenic means above the surface of the earth, that is on the surface or on the atmosphere, and endogenic below the surface. Biosphere. So each cycle that comprises two interconnected components. One is more exogenic, another is endogenic. Exogenic is above the surface of the earth, endogenic is below the surface of the earth. First, we'll see the carbon cycle. The carbon cycle, how it is moved from the atmosphere or from the exogenic thing to endogenic, again to the endogenic. So in atmosphere, carbon is present in carbon dioxide, carbon monoxide, and CH4. So it comes to the surface by some process. Then again, it will from surface or from land to the atmosphere. That is the cycle. So what are the processes that responsible that brings the carbon from the atmosphere to the earth? Then what are the processes that responsible that again escape to the atmosphere? First and main foremost thing, that is photosynthesis. With the main process, there is a plant used carbon dioxide from the atmosphere. So that's why from atmosphere it will come to the land and ocean by the plants. Then rainfall, that is acid rainfall, where the carbon dioxide mixed with water from bicarbonate ion, then it will fall on the ocean or land. Then dissociation, it is another, that is from atmosphere to ocean. So these are the process by which carbon dioxide will come from atmosphere to either terrestrial condition or ocean condition. Then in ocean condition, it is dissolved in water or in marine organism, that is use the carbon dioxide, and in marine sediments as carbonate sediments. Then when the oceanic plate that subduct at the subduction or convergent boundary, then it start to melt, then it will come to the magma. Any part that during the subduction, when it will melt, it will come to the mantle. Then from the mantle, it again come back to the ocean by magmatism. That is a divergent plate boundary. That is a divergent plate boundary. You can say it during magmatism or during also metasomatism at the divergent plate boundary. That is hydrothermal. Then from mantle it can escape to the atmosphere. From mantle it can escape to the atmosphere during volcanic eruption as carbon dioxide gases. So it is emits from the volcano. Then from mantle to plant and animal rock. That means the, from mantle any intrusion that happens within the rocks. So then during suppose the seal formation, dike formation, some carbonate mineral will deposit within the rock. Then they can alter through or they can be affected by carbonate metasomatism. So where the carbonate will deposited within the rock. Then again from land it can escape to the atmosphere by decay of plant. After death of the plant, when it will decay, it will emit carbon dioxide and CO2. Then during respiration process, carbon dioxide is released by animals. Then during the burning of the fossil fuel, also carbon dioxide and carbon monoxide is released. So these are the different processes that carbon from atmosphere to land or ocean, then to the mantle, then to the atmosphere again. And some of the carbonate deposition in the land part, it is by weathering and erosion, they can deposited within the ocean by your simple weathering process. That is carbonate that dissolve within the water, then it can erode and it will be deposited within the ocean as ocean sediments. Then it will again subduct. Then during subduction, the carbon will enter into the magma. Then with volcanic eruption or by intrusion, they all will come to the either to the atmosphere or to the land part. So this is your carbonate cycle. Understood? First thing we'll see what are the processes that bring oxygen from the atmosphere to the surface or to the land or to the ocean. कौन सा प्रोसेस है जो एटमॉस्फेरिक ऑक्सीजन ओशन तक या लैंड तक आता है. First thing, there are many metal that react with oxygen. There are many metal that react with oxygen. So the main important thing that is oxidation reaction. So that the example of roasting of iron or any metal, they react with oxygen. And another important thing your aerobic respiration. So during respiration we use oxygen. So that's how we can directly use the atmospheric oxygen. Another thing is your C1 metabolism. It is a type of metabolism that formed by organisms. So they used oxygen for C1 metabolism. C1 means any carbonate that consists of only single C, CH4 or CH, the carbohydrate. Those are C1 compound. So oxidation, that is the oxidation aerobic respiration. That is the most important thing that brings atmospheric oxygen to the surface. So oxygen can be directly used from the atmosphere, both in case ocean and land. So in case of ocean, there will be oxidation reaction and some of the oxygen that dissolve within the within the ocean. And then aerobic respiration, that is also used by organism within the ocean and also used by the organism within the land part. So these three process is common for both land and water that brings the oxygen to the surface. The only process that oxygen escape from the surface, that is photosynthesis. That is photosynthesis, where the plant they use the carbon dioxide and release the oxygen. So in case of the carbon dioxide, that is the process that bring the carbon dioxide to the surface. But here, that is the process that escape the oxygen from the surface to the atmosphere. And there is another process. It is a very small process, that is photolysis. That also, with the help of UV ray, it will convert the water to O2. That will also escape to the surface, escape to the atmosphere. The oxygen that is deposited within the rocks, basically. So they are erode and erode and will deposited as sediment in the ocean. That marine sediments, they can contain oxygen. So where during upliftment or during marine translation regression they will expose, and uh, they can remain as oxidation reaction. So during photosynthesis they can only escape to the surface. So most of the oxygens that trapped within our crust or mantle, only through a photosynthesis process that helps to escape the oxygen to the surface. It is a very small cycle. So there are 21% oxygen present in the atmosphere. 21, 78, 100%, 21%. Then is your nitrogen cycle. Nitrogen cycle. So nitrogen, there is 78 or 9% of nitrogen present within the Earth's atmosphere. So there is 78% of the nitrogen present in the atmosphere, but they are not directly used. So nitrogen cannot be used directly from the atmosphere. So there is some process that is responsible to bring the atmospheric nitrogen to the surface. The different mechanism is little complicated, थोड़ा complicated है. कैसे पूरा atmospheric nitrogen that comes to the surface and how it will circle through the Earth's surface, then again back to the atmosphere. First, we'll see what are the different processes involved during this nitrogen cycle. So these are the different nitrogen ions: ammonia, ammonium ion. Then we remember this nitrite ion. Then this is your nitrate ion. This is nitric acid. N2 is the nitrogen gas. N2 nitrogen dioxide. NH4 ammonium ion. NH3 ammonia. So these are the six main processes that transform nitrogen from one chemical form to another. That's how the nitrogen that circles through the earth and atmosphere. First thing with nitrogen fixation, then ammonia assimilation, then nitrification, assimilatory nitrate reduction, ammonification, then denitrification. So what are the process? First is nitrogen fixation. This is a process by which N2 is converted to nitrogen compound, which has a non-zero oxidation state. That means N2 will convert to NH3. It will be non-zero compound. There will be no iron, any process. Last thing, your nitrogen fixation by organisms, bacteria, they convert the N2 to NH3. They convert the N2 to NH3. There is rhizobium. like you can find in peas, beans and cyanobacteria. Plant जैसे यूज करता है नाइट्रोजन को NH3 को कन्वर्ट करके. So that's how nitrogen can be bring from the atmosphere to the surface by nitrogen fixation process. Another process that is nitrogen fixation is N2 plus O2 plus for electrical or fossil fuel energy, that will convert to 2NO. It is a process by which N2 can attend a non-zero condition, so that's why it is also a nitrogen fixation. Nitrogen fixation is not always performed by organisms. So it is also found in fossil fuel combustion in automobile engines and thermal power plant, where N2 is mixed with O2 with some electrical energy and fossil fuel energy. That means at very high temperature, you can convert N2 plus O2 to 2NO. But require very high energy, electrical energy or fuel energy during lightning, during combustion of fossil fuel. So they convert to NO, that is a non-zero oxidation state, that are also considered as nitrogen fixation. Whether it is converting to NH3 or to NO, they all are considered as nitrogen fixation. Then assimilation, that is the uptake of NH3 plus or NH4 plus, NH3 or NH4 plus by an organism. So any organism, when they take ammonia in different form to their biomass, because we require ammonia, so that is called as ammonia assimilation, how organisms that take NH3 or NH4 plus to its biomass. Then nitrification, so it is an aerobic process by which microorganism oxidize NH to NO3 minus per nitrate ion. So the conversion of nitrates to nitrates is very special for plants, and that process how the nitrogen is transferring from one place to other place. So this is nitrification, the process where microorganism oxidize NH3 to NO3 minus, that is nitrate ion. Then assimilatory nitrate reduction is the uptake of NO by an organism and incorporation as biomass through nitrate reduction. Then ammonification is a part of the general process of decomposition that converts reduced organic nitrogen to induced organic nitrogen. That means only decomposition where NH4 plus will be escaped. Then denitrification is also a process by which largely all the NO2 that escapes to the atmosphere. Because atmosphere there is 78% of nitrogen that is constant. So the amount of nitrogen that is come to the surface by this process, they also escape to the atmosphere by denitrification. So you can say this is the process that brings nitrogen to the Earth surface, and these are the intermediate process by which it circles through the Earth, and this is the process denitrification by which it will again back to the atmosphere. So you don't have to remember all the reactions, just remember the name. This is nitrogen fixation, this is ammonia assimilation. So these are the process that helps to circle the atmosphere, circle the nitrogen through the earth. So this is the cycle. For atmosphere N2, then first N2 it is by nitrogen fixation, ammonium oxidation, NO2 reduction, nitrification. They all convert to NH4. They are used by organisms. They can be deposited within the sediments. But the only process that is usually denitrification. That is denitrification that helps to convert again NO3 minus or anything that converts to N2. Then again here it will escape to surface. That escape to surface. But in Earth's atmosphere, N2 is the major gas. But we will also found NH3, NH, N2O, NO, NO2, HNO3. That's also present within the atmosphere. So that's why N2O can escape to the atmosphere. NO can escape to the escape to the atmosphere. NH3 can escape to the atmosphere. But there are a very little amount. N2 is the main source for nitrogen. So this is your nitrogen cycle. So you have to remember two processes, that is the nitrogen fixation by which from the atmosphere it will come to our surface, and denitrification is the process by which it will come again back to the atmosphere, and those intermediate process that helps to it circle through the earth. So N2 can escape, or it can also escape in form of N2O, NO, and NH3. Because these are also found within the atmosphere. The sulfur cycle. First, sulfur, it is very reactive element, so it combined with many oxide, many metals to form the ore deposits. Especially it combined with hydrogen to form H2S, and it also combined with oxygen to form SO2 and H2 that directly form during the volcanic eruption. Sulfur is also present within the animals or organisms, that also biologically active element that cycle through the food chain. Cycle through the food chain, sulfur. So this is the geochemical cycle of sulfur. We'll see what are the different processes that helps to bring the sulfur from the atmosphere. As rainfall. Rainfall can bring SO2 in form of acid rain. Then dry deposition. What is dry deposition? During volcanic eruption, they can deposit as SO2 plus or SO4 plus, SO4 2 minus or SO2. Volcanic eruption eventually the atmosphere में हिजो ना. Volcanic eruption जोटा आर्थ्र मैंटल जो पार्ट रो जति आसीबो सेतले से एक्सप्लोड हबो. So एक्सप्लोड हेले क्वाड गला. आज केते को डिपॉजिट भी हबो ना. आज आस कंटेंट हिसाब रे डिपॉजिट भी हेबो ना. आज आस कंटेंट there are basically finer patterns. No, no. Some can be deposited as material. So these are the two main process by which atmospheric sulfur can come to the surface. So they can also react with any metal to form economic deposition, that is any sulfide, that is copper sulfide or PB sulfide, all things. Then it will deposit within the marine sediments or within the land part, within plant or animal as biological element, or in rock as sulfur or any rock element or mineral element. In ocean, it can form, it can remain in dissolved form or marine sulfide form, in sulfide or sulfates or sulfide. The same thing that is we have studied in carbonate, it will subduct, then again it will go to the mantle as magma. Then from the mantle it can erupt at divergent plate boundary, where it can deposit it as sulfide compound, that is your BMS deposition, volcanogenic massive sulfide deposition at mid-oceanic reef. Then again the same process, intrusion as seal or dike within the rock, and also metasymmetry. Those are the processes that deposited within the rocks, and it also can escape to the atmosphere directly by volcanic eruption, like the carbonate. So this part is totally similar to carbonate cycle. This part is not totally similar to carbon cycle. So these are the process that brings all the atmospheric sulfur in form of SO2 or H2S or DMS to the earth surface, then to the mantle, then to the atmosphere. Then what are the other processes? From the mantle it can directly to the atmosphere by volcanic eruption. But there are other processes that helps to escape the sulfur to the atmosphere. Then first fossil fuel biomass burning. So during fossil fuel or biomass burning, it releases sulfur. A similar thing also happen in industrial process, because industrial process has more SO2, H2S. Those are you can say the pollutants. So they are in industrial process. They are in pollutant case they will to the atmosphere. They will escape to the atmosphere. So it is not in industrial process. It is a waste product. So then bacteria also reduce some, and it is escape to the atmosphere. These are the process by which both from the land part and from the ocean part it will again back to the surface. Another thing that is only occur at oceanic condition, that is sea salt. So at sea salt they can escape to the atmosphere. So these are the different process that helps the sulfur to cycle through from atmosphere to the earth surface to the mantle, then to the atmosphere.